Hi, good morning, and welcome to, I should say good afternoon here, but welcome to the FoodSense webinar. So this is one of our weekly webinars that we use to really support in a technical manner people who are using the FoodSense technology. So though I'm showing a lot of images of chili products today, I'm actually today talking about measuring the potency of ginger. And I'm doing this or we're doing this rather, in an objective manner in the units of ppm, parts per million. I say here digitization and traceability in the supply chain. So though I haven't introduced FoodSense, FoodSense is a technology. It's a very sort of handheld device that can measure the capsaicin in chilies, the gingerol in ginger, and also total antioxidative status as well, or TAS. Total antioxidative status is actually quite interesting because I'm talking about ginger today, and one of the kind of medicinal properties, or one of the kind of benefits of ginger and ginger products, is they're sort of described as antioxidants. Well, you can actually measure that property directly as well using an assay called TAS, or total antioxidative status, which actually I will touch upon a few times today in this webinar. But let me go forward. I will speak fast because I want to be really efficient with people's time. Just a quick introduction to ZP. You know, we're the developers and manufacturers of this technology. We've been around now, coming up to our 10th year when it comes to 2024. We're ISO 13485, so a lot of what we do is really for the medical industry, getting people through regulatory approval and getting people onto the market for doing human diagnostics. We are contract developers, contract manufacturers, specifically of electrochemical biosensors. A good technology for doing what's called point of care in this world is electrochemistry. If you look at glucose strips for diabetics, they're all electrochemical. And when you look at the FoodSense technology, you realize it's actually a very much more akin to a medical product than necessarily a kind of product that's traditionally used in the food industry. We have a fairly sized facility, and we're based primarily in Norway and UK. And we also have a international strong scientific team. The team is important because later on you'll kind of see that one of the big things about FoodSense, and in particular the case study that I'll show you today about measuring ginger, is the transparency. And the fact is, there's a certain transparency that we can see the raw signal. It also means that if you decide to share the data with us at ZP, we can also support you as well. We have quite a strong team in order to do that. So just to say about FoodSense, everyone gets personal online training. So if you're a FoodSense Gen 4 customer, you get personalized online training. We do weekly webinars. So here I've got to answer some technical questions that have come in during the week. And we also do monthly webinars as well. We do the monthly webinars. The next one's in January because we want to demonstrate the robustness of the technology. That, for example, in the monthly webinar, we take a ginger shot, we sample it directly, we put it straight on the sensor, we get a result, done. That means there's a certainty, you understand what's happened to the sample, and you get a result there and then, and it's a lot lower cost than trying to do HPLC. And you can also do repeats, so you can understand, you know, how certain am I actually in that result, which is something you can never do with an HPLC test. So this just reminds me that we do have a webinar on the 25th of January. If you see a link jump up, I will put the links underneath the video as well, which I'll put on YouTube as well. So that said, going forward, this is the FoodSense Gen 4. We've obviously done, you know, we actually ended up doing a FoodSense Gen 0, Gen 1, Gen 2, Gen 3. So there's been a real sort of maturing of this technology over the years. This is not just something that just turned up of recent. This is something that's been evolving over the years. So it's now smaller, it's easier to use, it is more accurate, it is cloud enabled, because cloud enabled is important. So the data that goes to the cloud is your data, it's behind your username and password, but it does allow you to share data with us if you want us to kind of confirm that everything is working okay. So we have, for example, ginger customers in Indonesia. It's great because I can see their data and confirm everything's good. I've also got chili customers in India, which is great. They do a test, results go up to the cloud, they can share those with us, and I can confirm that everything's good. I could do things like extra statistical analysis on their data, etc. So that works out really well. It is multiple analytes. So now with Gen 4, we've got chili, ginger, and we also have total antioxidative status on it. And it, as I said, it's interesting that ginger and TAS actually are quite complementary together. This quick video here shows the hardware. The hardware, as I say, is an elegant piece of hardware. There's no sort of funny little slot where you have to kind of slot these sensors into. It's all hinged, and you get a sort of nice way of putting the sensor into it. We have a total system, where, as I say, from sort of sensor through app, and I'll talk about the app in a minute. You run the assay, the data appears on your phone there and then, but also the raw signal is actually stored up in the cloud as well. It's easy to go between the different tests. If you're want to do TAS or chili or ginger, you just scan the different QR codes, and that will allow you to access those different assays. For each one of those assays, by the way, is a different sensor. So it's a different QR code and a different sensor for each of those assays, but it's the 1 meter, which is good because then you can essentially do 3 tests on the one piece of hardware. If you're watching the video, you can essentially pause it in a minute because this is a QR code. If you get somebody with an Android phone to scan this QR code, it'll take them to the Google Play Store. They can download the app, and then when they open the app, it will ask, and they've created an account, it will ask them to scan a QR code. It will ask them, do you want to do a chili assay? Do you want to do a ginger assay? Or do you want to do a TAS assay, a total antioxidative status assay? Just out of curiosity, TAS is both a measure of, how do I say this? It's a measure of antioxidative status. It's also a predictor of shelf life as well. If you've got a high TAS score, then you're basically resistant to kind of oxidation, and therefore you've got a longer shelf life. If you do come to our webinar on the 25th of January, we will do a live chili and a live ginger testing there and then, so you can really see the kind of ease and robustness of this, especially ginger, because ginger, well, ginger's got two, sometimes you've got roots. Ginger root is fun because you have to kind of grate it up. Ginger powder is easier because it's already essentially grated up, and then you've got people with ginger shots and ginger products. These are easiest because they're the most sort of homogenized products. Just as a side note, at ZP, as I said, we are ISO 13485, so we do a lot of medical products. So you can actually see that if you ever came to our website, I'll just put a quick link to it here, we've actually got a lot of sensors. So if there's something on here that would also be interesting in the food and supply chain, food and beverage industry, and in the supply chains, let us know if something's here. For example, I think glucose could be sometimes interesting to people. We do have malic acid, which I think is sometimes interesting to people sort of in the cider and the wine industries, etc. So if you see something up here that fructose is in here as well, if you see something that's, or pH is also up here as well, if you see something that's interesting and would also be nice to come onto that FoodSense platform, do let us know. The problem that we're sort of solving is we want to qualify that ginger is there, as also quantify that ginger is there. So there is analytical testing on HPLCs. People generally don't own the HPLC. They are sending it out to third parties to do this. Why HPLCs are expensive? They're hard to run. They're hard to maintain. They're full of organic solvents. So the kind of cost of ownership, unless you've got a lot of testing going on, the cost of ownership, you just can't own it. You're better off essentially renting the service. You've got people doing organoleptic testing. So this is a shock, but I do find that people who have actually quite large businesses actually are mostly doing quality control by testing. And then you've got FoodSense, which gives you the benefits of the HPLC, but at a fraction of the cost. So the HPLC is expensive either to use as a service or to own outright. When I say under testing, because it is expensive to use and expensive to own, people don't do that much testing. And maybe what we're definitely finding is actually that people are doing a lot more testing now, so have a lot more certainty. So for example, if you have a ginger powder, it's a heterogeneous sample. So if you've got a bag of ginger or a pallet of ginger or a shipping container of ginger powder, where you sample from can give you different results because the entire batch is not homogeneous, it's heterogeneous. So people tend to do under testing with HPLC because it's expensive. Whereas with FoodSense, actually, they can do a lot more testing and understand the average and the range of pungency across those ginger products. It's slow results, so you take a sample, you send it out to a lab, you get the results sent back sometimes, in the distant future. And I would describe it as a sort of black box with no sense of error. When I say black box, there's no transparency to this. You would get an email back with some results in it, and it's a trust thing. I get it. Trust is good. It's good to trust people, but you really have no vision on, the error associated with that number. So whenever you get a number, especially in the food industry, it should be plus or minus some error. But what I'm noticing is that it's not. These numbers are coming through as absolute numbers. No indication of error whatsoever. So FoodSense It's much lower cost. It's lots of testing is now possible, and it's quick as well. Come to one of our demos. Fast results, which is linked to, you can therefore do lots of testing. And it's also a very transparent process, and the transparent process is important. I'll do a case study in a minute where I'm going to show you that we report the ppm, and I'll show you 3 samples, low, medium, and high, and it's in the raw data. There's no doubt about it. It's in the raw data. You can't make up the molecule, and it's quite, it's quite clear. So when I say black box, so let's say you have a ginger sample and you send it off to the lab for testing. The first thing is that sample you're sending off might not be representative of the entire batch, and so you should really be sending, let's say, 5 samples from the main sample just to get a statistical analysis on this, but you can't because it's too expensive. There's processes going on in that lab that may include extraction and possibly filtration as well. I'm absolutely sure it must do filtration. They definitely have a dilution because the gingerol is at quite high concentration. It'll definitely overwhelm the HPLC system. That's because it's probably using a UV vis detector. There's an injection onto the column. That's probably fairly repeatable. Sometimes it's manual injection, but most of the time they have a carousel device, and the needle comes down, pierces the lid, takes the sample up. Then you have a chromatogram. So the point is, there is a raw signal here, and it's the chromatogram showing the kind of the peak linked to the gingerol molecule. But then there's also a conversion of raw signal into a concentration. So you get a concentration back, you're happy with it, but you have no idea really but these steps, so you weren't there to witness them, let's say, and you weren't there to understand, looking at that raw signal and looking at that calibration, did that calibration take place of the HPLC system on the day, on that week, or in that month, or in that quarter? So by the way, HPLC systems, they're multi-component devices, solvents, pumps, UV detectors, columns that get replaced. So they have to be quite frequently calibrated for each particular assay. The longer the time between calibration and your result or your sample being run, then the greater the error. But you have no idea about, it's a black box. You don't really know when calibration has actually taken place. So HPLC is expensive. There's no transparency to it. It's basically based on trust. And there's no indication of error. So here I've shown like 5 steps. The sampling itself can introduce an error. The extraction can introduce an error. Dilution can introduce an error. Injection can introduce an error. There's an error associated with actually gathering the raw signal, and there's an error associated with calibration. All of these things, they can stack up. So if you just put like a sort of something like a sort of 5% error for each step, you can end up with errors of like 25% or more. And those are quite conservative errors. But what you notice is that there are no errors indicated when you get the number. So people don't understand that actually that number they're getting is plus or minus some percentage. It's taken as, as it must be the truth. If you took the same sample and sent it to 3 different labs, so if you took a ginger powder, sent it to a lab 1, you get a result. If you sent the ginger powder to a lab 2, you get a result. And if you sent the ginger powder to a lab 3, you get a result. You would not get the 3 same results. If you sent the same sample to the same lab with a label, you'd get a result. If you sent the same sample to the same lab at a different time with a different label, you get a different result. And if you sent the same sample to the same lab with a different label at a different time, you get a third result. So I'm just saying that there's what we would call inter-lab variability. No 3 labs will give you the same result. And I bet you if you sent the same sample to the same lab on 3 different occasions and labeled it up differently, you get 3 different results as well. And this is really reflecting the underlying error associated with measuring molecules like gingerol on HPLC systems. People have no sort of thinking about necessarily the error that's associated with this. Just to say, we obviously have an alternative way of doing this. It's much faster, much more transparent, and much lower cost to do. The technology that we've done is licensed from the University of Oxford. There's a gentleman there called Professor Richard Compton. And we are using a technique that is electrochemistry, in particular using a technique called voltammetry. The one thing about molecules like gingerol is they've got very distinctive signals. So we can clearly see that actually we've got, let's say, gingerol, and we can tell from the intensity of these peaks how much gingerol is in there. So when we give a number on the smartphone, in the background, we've also got the raw signal, and the raw signal is available to you. You can look at your own raw signal and actually check that everything's right. So when I was talking about HPLC earlier on, I was saying, look, there is a raw signal behind your number, but you've no indication of the raw signal. You've no indication of the calibration. But with the FoodSense, you do have a transparency on this. So, you take the sensor, you put it in the Gen 4 meter. The meter, I've already talked about the app. The app will tell the meter what to do. The app will communicate with a cloud system called Julie. It's your password, it's your username, it's your data. Put the sensor in the meter. You put the sample on the meter. The meter tells the app what to do. The meter gives the data back to the app, and you will get a result on your device. But it's also storing the data up in the cloud as well. So this is about transparency, and it's also about traceability as well. If you're ever challenged, you can bring this fingerprint up and essentially demonstrate that, why you're saying what you're saying about the pungency of that particular product. So you'll get the results on the phone, but then, which will give you basically speed and certainty. And what I mean by speed and certainty, you've done the test yourself, so you have a greater degree of certainty as to, what this is. And if you're unclear, and if you're not sure about it, you could do the test again or a third time to give yourself that certainty. Whereas you can't do that with HPLC, because you're going to potentially, I think the range is between 50 and 150 euros or dollars, depending on where you are in the world. So people just don't do multiple testing. But we do actually get the raw data, the whole thing. So that gives us transparency. And then, as I say, because we've got that, if people are really doubtful, they can actually then invite us to the data, and I can look at the data and check that everything's good. So the support is excellent as well. We're also, because we are cloud enabled, we have what's called an API, an application program interface, which makes us compatible with modern LIMS or laboratory information systems. If you've got some way of kind of databasing all of this, then we can probably plug between our database and your database. Talking about voltammetry a little bit, obviously in doing this work, we've made sure that the fingerprint for gingerol is increases with gingerol concentration. And when we do people's, let's say, samples, we literally get this voltammogram. We know it's ginger because we can see it in the shape of the raw signal. And the intensity of the raw signal tells us how much gingerol is in there. So here's a case study where we had these suspensions, if I can say that, of some sort of ginger powder, and we were measuring them. I'm going to label them up in a minute. The way we measured them, we measured one of them at 4,784, which I labeled up low. We measured one of them at 6,095, which I measured up, which I've labeled up medium, and we had one of them that was at 16,375, which I've labeled up high. Now the question could be, well, how do you know that's really true? And the answer is because I can see it in the raw data. Here I've got intensity, and here I've got concentration. So what I'm saying is that as the intensity increases, the concentration of gingerol in ppm increases as well. So for their low sample, I can see, whoops-a-daisy, for their low sample, I can see the raw signals. We did it multiple times. For the medium sample, I can see the raw signal. We did it multiple times. It's quite nice because you can see that, these three curves are not exactly on top of each other. I'm not criticizing us, but it will always be the case that when you're measuring complex samples, you should get variation, and that's a transparency about us. But I can see that we're really much, that is low, that is medium relatively, and then there was one that was high, and with the screenshot that I've used, it's basically off the scale, so it is high. We can't make these numbers up. These peaks are the molecule. It's not like an artifact or anything like that. No, this is the molecule, and we definitely got our ranking correct. The other way of doing this, obviously, is to do the HPLC and sending out to a third-party lab. But honestly, you don't have a vision as to what's really going on in that lab. So let me just do a quick summary at the end here. So at ZP, if you're a FoodSense Gen 4 customer, we are here to help. I do webinars every week. I'm always answering technical questions from that customer base. If you have an analyzer application that's currently not on the platform, you've seen that, we're quite comprehensive sensor developers. Let us know. We'll be kind of interested in having a chat about it. If you are a FoodSense Gen 4 customer, everyone gets personal online training. We've got a laboratory. We demonstrate from our laboratory. You can demonstrate back to us, and we can test each other's protocols. We do the weekly webinars. Here's one of those weekly webinars where I'm essentially touching upon some technical questions that have come in. And then we do have the monthly webinar on the 25th of January. If you're interested in FoodSense and in particular interested in seeing a live ginger test, come to the webinar and see it happen for real. And then just lastly, there's a really nice transparency. This is the thing that kind of makes me feel like, so confident in this technology. There's a transparency that if you're a FoodSense Gen 4 customer and you do a test in the lab, you'll get the result. Great, put it in your record, no probs. If you want to have a little look under the bonnet of this car, you can lift the lids and have a look at the raw signal. And if you want to question or challenge it, you can share that data. You don't even have to, you can literally, I give you my email address, you invite me to the data, you didn't have to send anything to me, it just allows me to see your data at that point. So then that's a kind of level of support that is only really come about because of the, we live in a modern world with cloud connectivity. So lastly, just come to the webinar on the 25th of January if you're so interested in FoodSense, and we'll do a chili and ginger demonstration. If you want to see a task demo as well, that might be interesting, but just let us know by contacting us before the webinar, which is a good point because I've got a contact us link here, and I will put this underneath the webinar video now, I should say. Okay, thanks. If you've got any questions, please don't hesitate to reach out to us. Thanks so much. Bye-bye.